Hello everyone, this video is to show you how to find the sampling error of the sample mean. So before we go about and look at our samples that we've found and look at any of that, we need to find our population sample. So our population is obviously all of the baseball teams that we've been looking at in previous videos, and we're going to look at the data set for home runs, hit, and allowed. So before we can get into our samples, we need to know what's the mean of all this data. And by now, I hope that you have that data analysis tool downloaded and added into your Excel. So we're just going to use that because that makes it a lot quicker. And we're going to do our descriptive statistics. Click OK. And we now need to find our input range, so our data set from B2 to B31. And then my output range, we're going to have the output be down here below it, so A33. And you want to make sure that this summary statistics is checked. And we click OK. So we find that our mean is 76.8, standard error, our median, our mode, our standard deviation, all of those things. All right. So now, in order to calculate the sampling error of the sample mean, we need to take the sample mean and subtract the population mean. So if we look, this x with a bar, so x bar is the sample mean. And this is our population mean. So our population mean is that 76.8. So it should be up one. Sorry about that. All right, so our population mean is 76.8. That's never going to change, so we're going to absolute reference that with that function F4 or F4, depending on what your keyboard looks like. And it didn't want to do that, so we got to come back and do that again. So I accidentally clicked out. There we go. All right. So now what we need to do is we need to look at our random sample and come up with the means for those. So we could do it in one of two ways. Again, I'm just going to use my data analysis package and that tool. And we're going to change our input range to just those 5. And my output I'm going to put up here in G1. Summary statistics, okay. And I'm going to relabel this. Instead of column 1, I'm going to put 5 sample. So that way I know that this is the mean from that sample. So my sample mean is now going to be 75. And when we look for our sampling error, we'll do sampling error for the sampling error 5 sample. We're going to equals our sample mean minus our population mean. And we get negative 1.8. And now we're just going to repeat that with the 10 sample, the 10-point sample. So again, I'm going to do my data analysis. I want descriptive statistics. I want that E column because I want those 10 data points. And I'm going to change my output range so I don't cover up that. We're going to put that in J1. Summary statistics. Click OK. Here my mean is 76.8. Which is actually pretty cool. And I want this to be my 10 sample. So we want our mean to be equal K3. I'm going to pull that over. And randomly, we have the same thing. So when we find our sampling error, and we take our sample mean minus our population mean, we actually find that it's 0. If we wanted to do a different random sample, we would more than likely get a different answer there. But you can tell that these are all different, that I found my 10 sample. And that it's not the actual overall population sample because my standard error and my standard deviation are different. So it just happened that we found a sample where the sample mean is the exact same as the population mean. That will not always happen. So let's actually do another one. Let's find another random sample quick. Sampling. B2. We want to go all the way down to B31. We want a random of 10. We want to put that in M3. Okay. And now we want to do the descriptive statistics for that one. I'm going to put those in O1. And we're going to change that output so that or our input so that we're doing that last sample I took. Click OK. And here we'll see that our sample mean is just a little bit above that 76.8. So if we do that one for a second set, we would take our mean, subtract our population mean, and we get 0.1. What you should see, and it's not always true, but what you should see is that as your sample gets bigger, the sampling error gets smaller. So the more you have, the bigger your sample size, the closer your sampling error gets to 0. And that's how you find a random or a sampling error when you have the sample mean.